Today we'll see family of quadrilaterals. Here I have shown this family. You can see that there are 9 members with this as grandparent, maybe Dada, Dadi, Nana, Nani, and then you have all these things. So let us see one by one the properties of the quadrilateral. If you just say quadrilateral, then we get here a polygon with 4 sides and 4 vertices. There are 4 angles also. See, if I click on angles, you'll see all these 4 angles, and you'll see that they may all be different. Similarly, the sides also may all be different. After seeing these angles, let's see that it must have the diagonals. So it has 2 diagonals. When you join the opposite vertices, you get the diagonals. Now, one more property of this triangle, that it can have any shape in the sense, supposing I move this anywhere, all these are the quadrilaterals. I can move any of these and still this will be quadrilateral. Now if by chance if I move this in this fashion, where one of the angles is known as re-entrant angle, or angle which is more than 180 degrees, then we call this type of quadrilateral as concave quadrilateral. All other quadrilaterals are known as concave quadrilateral. Now here the peculiarity is that one of the diagonals is going to lie outside the area of quadrilateral. Okay. Now let's go ahead and see the next quadrilateral, say parallelogram. Now here you will see that you have these 2 sides equal. These 2 sides equal, and naturally when these 2 sides and these 2 sides become equal, they are also parallel to each other. That we can see by clicking on the angles. You will see that if you add up these 2 angles, it adds up to 180 degrees. These 2 angles add up to 180 degrees. These 2 add up to 180 degrees. So these lines are parallel to each other. Opposite sides are parallel to each other and they are equal. Opposite angles are equal. Okay. Now let's see what about the diagonals. Okay. Now if you click on the diagonals, you'll see that diagonals are cutting each other in equal parts, but the diagonals themselves are not equal. The angle is not 90 degrees, that is, they are not cutting each other at right angles. Okay. Let's see whether there is a symmetry. Okay. Now there is no symmetry here, because you cannot draw a line wherein you can divide this in 2 parts which are mirror images of each other. Now to find the area of this, the simple thing is that you find the altitude and then base multiplied by altitude will become the area of this parallelogram. Now let's go ahead and see rhombus. Now here you can see that this is a special case of parallelogram where we have all these sides equal, opposite sides are parallel to each other. Now let's see what are the angles. You see that because sides are parallel, the adjacent angles add up to 180 degrees and opposite angles are equal. Okay. Now let's see what is the property of the diagonals. Now here, because these 2 sides, all the 4 sides are equal, you see that the diagonals cut each other at 90 degrees and they also divide each other. So you have a simple way of finding out area of the rhombus, that is, you just multiply these two diagonals and divide by 2, because we are having 4 right angle triangles here with half as the base of each of the diagonals and the height. Okay. Now let's see what about symmetry. Okay. You see that these two diagonal are also symmetry lines because they are dividing the rhombus into equal parts, the mirror images of each other. Now let's go ahead. You see that you may change all these shapes, etc., and still you will have the rhombus. Okay. Now let's see the rectangle. Now rectangle is a special case of parallelogram. Rectangle is a special case of parallelogram where you will see that the angles are all 90 degrees. Okay. And it has the property of the parallelogram in the sense opposite sides are equal and parallel. Okay. You'll see that opposite sides are parallel and equal. You may modify this any way you like. Right. Now let's see how the diagonals are behaving. So if I show these diagonals to you, you'll see that diagonals are cutting each other, bisecting each other exactly at center of gravity, but you will see that they are not necessarily cutting each other at 90 degrees. Okay. Though they bisect each other, they don't cut each other at 90 degrees. Now, what about symmetry lines for this? For symmetry lines, you will see that the mid sides, that is midpoints of the sides, if you join, then you will see that it cuts in two parts where you have this part mirror image of this part mirror image of this on this particular symmetry line. Okay. To find the area of this is very simple. You just multiply the two sides because this happens to be the altitude of this if you consider this as a parallelogram. Okay. Now let's go ahead and see a spatial quadrilateral square. See, it has all the symmetry properties. Okay. See, all 4 sides are equal, all 4 angles are 90 degrees. You'll see that here. Okay. Now, if you see the diagonals, you see that the diagonals are equal. They bisect each other in center of gravity and they are meeting at 90 degrees. Okay. Therefore, to find the area of this particular square, you will see that you may multiply these two sides, that is square of one of the sides, or you may multiply the two diagonals to each other and divide it by 2. Okay. Let's see the symmetry. Symmetry, you'll see that you have got 4 axes of symmetry. Now it's a general rule that if you have a parallelogram which is regular, then it has the symmetry lines equal to the number of sides. That is, if you take equilateral triangle, it has symmetry 3. If you take square, it has symmetry 4. If you take regular pentagon, it has symmetry 5. If you take hexagon, regular hexagon, it has symmetry 6. Okay. Now let's go ahead and see the properties of kite. See, kite, well, what really happens is in case of kite, see, you have 2 sides, adjacent sides equal. These 2 are equal, these 2 are equal. And hence, what happens is, you see that one of the pairs of the angles, they are equal. Opposite angle pair is equal. Only one, not the other one. Okay. Now let's see what about the symmetry lines. Okay. Now you'll see that because these 2 angles are equal, these 2 sides are equal, other pair is equal, you get a symmetry line here at the center. Okay. Now next comes the diagonals. Okay. You see that the diagonals cut each other at right angles. Okay. This diagonal gets bisected, this diagonal does not get bisected, and therefore area formula becomes very, very simple. Okay, you just multiply the two diagonals and divide it by 2, you will get the area of this particular quadrilateral. Okay. Now another special quadrilateral is a cyclic quadrilateral. Now in this cyclic quadrilateral, you see that all the 4 vertices, they lie on a circle, and therefore you get very special property of this particular quadrilateral, that is, you have the opposite angles adding to 180 degrees. It's very simple to prove that, because if you join this at the center, you will see that this particular angle and other angle, they make 360 degrees, and therefore the opposite angles sum becomes 180 degrees. Okay, so you will see that if I change this shape, you see that the angles still add up all the time to 180 degrees. Special case of quadrilateral. Then see the sum of opposite angles is 180 degrees. Okay. Now to find the area of this particular thing, Brahmagupta has given a formula, a very ingenious formula. He defines S as the perimeter divided by 2, and then the area you get as under root x, S minus A, S minus B, S minus C, S minus D, where A, B, C, D are the sides of the quadrilateral. You may note here that if I connect this to this point with the other one, you get a triangle. Now, area of the triangle given by Heron's formula is the same formula. That is, if you drop one of these sides, this reduces to Heron formula. Let's see what about diagonals. The diagonals need not cut at 90 degrees. They need not bisect each other. Now let's see the next one, the trapezium. Simple rule of trapezium is that 2 of the sides are parallel to each other. Okay. Then you see that you don't have any symmetry line, don't have any property, special property for the angles, nor for the diagonals. Okay. You don't have symmetry line, and if you find the altitude, you see it's very easy to find the area if you know this altitude. That is this side plus this side divided by 2 multiplied by this. That happens because if you join this diagonal, you will see that you have 2 triangles here with base this side and this side with this as the altitude. So you get the area of this. Now one of the special kind of trapezium is known as isosceles triangle. See, isosceles triangle. Now here you will see that the 2 sides are parallel and other sides are equal with equal inclination. Okay. So if you extend this, you are going to get a isosceles triangle. See? Here again you will see that 2 pairs of angles are equal. Okay. 2 pairs of the angles are equal. There is no special property so far as the diagonal is concerned, but the diagonals are equal to each other in the length. Okay. What about symmetry line? You do get a symmetry line here which is joining the midpoints of opposite sides. Okay. Then the same line is also altitude. So to find out the area, you can just take this altitude multiplied by sum of these 2 and divide by 2. Thus, we have seen here a great family of the quadrilaterals. Probably in the lower syllabus, excepting cyclic quadrilateral and concave polygon, you are going to study all this.